This is the first introduction that protagonist gets to inverted time with this woman we never see again, who sort of explains negative entropy.
Mhm.
It's kind of a confusing scene. Let's see what we see.
Aim it and pull the trigger.
It's empty. How?
One of these bullets is like us, traveling forwards through time. The other one's going backwards. It's inverted. Its entropy runs backwards. So to our eyes, its movement is reversed. We think it's a type of inverse radiation triggered by nuclear fission.
So the entropy is running backwards, triggered by, what did she say? Radiation?
Yeah, maybe.
It's a type of inverse radiation triggered by nuclear fission.
Inverse radiation?
So I thought that was just technobabble, because what is inverse radiation? I mean, I guess you could say if something is in forward time and something's radiating out, then if something's radiating back in, then that's inverse. Sure.
Okay.
For me, the thing that she said there was, she said negative entropy or inverse entropy. How did she say that?
Inverse and
Or negative?
Let's see here.
Further back.
Inverse radiation triggered by nuclear eyes. Its movement is reversed. We think it's a type of inverse radiation
further back than that.
triggered by
Further back than that.
Yep.
going
He's
backwards.
like, how?
It's inverted. Its entropy runs backwards. So to our eyes,
Okay,
its
entropy
movement
runs
is
backwards.
reversed.
Yeah, entropy runs backwards.
So first, I guess we should explain time's arrow. So
Okay.
the second law of thermodynamics is that the entropy S, or I guess the change in entropy delta S, is equal or greater than 0. So you have a process that happens, and the entropy should be always increasing in the plus direction. And so
Yep.
this is an example of this is an ice cube. See if you have two photographs. One is a sidewalk, and there's like a thermometer, so it's like 106 Fahrenheit outside. And then you have a second photograph, and it's a puddle of water. And so the ice cube is a low entropy state. The melted water is a high entropy state. The atoms are zipping around all over the place. And so time's arrow points us in the direction of increasing entropy. So you see an ice cube and then a puddle of water, you can say the ice cube came first, it got melted into the puddle of water. And so that's the time's arrow aspect. So if you were to reverse that and you said, if water could go from the liquid state and then form itself up into a cube, then that's reverse entropy. That's entropy going in the negative direction.
So my question would be, in the real world, I think we can reverse entropy for non-isolated systems.
Right.
So like we can take the puddle and make it into a cube,
Yep. Put it
It's
in an ice
just-
cube tray.
right? Put it in an ice cube tray, which the entropy for that water is going down, but the entropy for the outside, the rest of the universe, is going up by more. So overall, the entropy
Exactly.
of the universe goes up. But we can reverse the entropy of single objects if we
Yeah,
wanted
absolutely.
to.
So you put the water in the ice cube tray, and then
Yeah.
you pump out all the heat. That's why your refrigerator is making sound. It's the compressor going on every once in a while. And so you're taking all that energy, which is causing the atoms to zip around, causing entropy, right? You take that
Yep.
energy, you pull it out, you shove it out into the rest of your kitchen. You say, rest of the kitchen, you deal with it. So you can locally decrease the entropy. But that's not what she's saying here. She's saying, no, just straight up, don't have to worry about locality, about whether you have an ice box or not. It's just the whole scenario, the entropy is decreasing.
Right. So she said like the bullet itself, the inverted bullet's entropy is decreasing.
Right.
Not like a regular bullet would be, or a regular object where we decrease the entropy in going forward in time. She's saying it's like somehow always going against time.
Right.
There's like a entropy of the universe going in one direction, and the entropy of the bullet is somehow going in the other direction in some fashion.
Right. That's also how I interpreted what she's saying.
Because the water, it's always increasing in entropy. If we turn it around and freeze it into a cube, the entropy goes the other direction temporarily, and then it continues on going higher again.
Once it melts
She's
again,
saying-
yeah, I'm sure.
Once it melts again, yeah. So, half, okay.
Okay, so that's the key premise. That's the key, the kernel of an idea, of a scientific idea, is that if you could break the second law of thermodynamics such that the entropy could be the net change of the entropy could be negative, then what happens?
Yeah. Okay, let's continue.
So where did it come from?
Someone's manufacturing them in the future. They're streaming back at us. Try it. You have to have dropped it
How can it move before I touch it?
from your
How does that? She said you had to have dropped it, but I didn't drop it. I will have had dropped it.
Yep. Time gets complicated very quickly.
Yeah.
So I guess what she's going after here is causality, because one of the key tenets in physics is that things happen only after you do something to it. There needs to be a cause for a reaction to happen. Otherwise, some things will be reacting to nothing. What are we reacting? So she's setting up a rule that you have to drop it. You have to drop the bullet in order for it to later come back into your hand.
That's right. But that doesn't really make any sense because he did not drop it. He inverted dropped it.
Which is picks it up.
Picks it up.
Okay.
All right here. So it's going to pop into his hand.
Mm-hmm.
And if you run time the opposite direction, he will have dropped it.
Right.
But since we're in going forward in time with the universe, it looks like the bullet popped up into his hand.
Mm-hmm. But in the future, he will have dropped it. So that counts in the past. Going forward, time is picking it up.
I think he never picks it up. It's either a drop or an inverse drop. Because he doesn't like pick it up. Like he just drops it.
Okay.
Going
Yeah. I meant pick it up as in like an inverse drop. Is it going into my hand as a pickup?
Oh, I see.
Yeah.
Okay. Let's continue.
How can it move before I touch it?
From your point of view, you caught it, but from the bullet's point of view, you dropped it.
But cause comes before effect.
No, that's just the way we see time.
Well, what about free will?
Bullet wouldn't have moved if you hadn't put your hand there. Either way we run the tape, you made it happen. Don't try to understand it. Feel it.
Protagonist is a philosopher. He went straight to free will. He went way over there.
Well, I mean, that's one of the resolutions of like time travel paradoxes is that determinism reigns, and so there is no free will. Just everything is set in stone.
Can you slow that down and explain that a bit?
So, if you go back in time and do something that changes your history, say you kill your grandfather, which means you were never born, which means you could never go back and kill your grandfather. Well, if you have complete determinism, then everything is already set in stone. So there's no way for you to go back and change history. Whatever you do will already have happened. You had no free will in the matter. So having no free will is a resolution to time travel paradoxes, potentially. So somehow he jumped right to free will. He was like, oh my gosh, free will.
Yeah, this guy thinks very quickly.
Yeah. And then there's so many paradoxes just sort of creeping up here that the woman is like, well, feel it.
Feel it? Okay, yeah. Don't worry about it. Don't worry about it.
Don't try to understand it.
Yep.
What are you, a physicist? Don't try to understand it.
I mean, gosh, in some sense it makes sense because we live in 3D, we live in XYZ, and we live in time, kind of. But we can go forward in positive X and negative X, but we can't go negative time. So our brains really don't handle negative time well. Like we're just not suited for it. So what she's saying is like just feel it. You get an intuition. Don't try to analyze it.
Right. Which is kind of the right thing to say because if it would take years to build up a mental or a theory about how this works, and she's got to go do a mission right now, don't worry about it.
Don't worry about it.
Don't worry about it.
Yeah, like don't worry about the engineering of a plane. If you can fly it, just fly it. Like don't worry about it.
Yeah.